Okay, so we've just finished our chemical equations unit. Now we're going into our first segment of our stoichiometry unit. So stoichiometry is basically going to be the math behind chemical equations. So these problems that I have here are the first type of problems that we have to solve, which are mole ratio problems. These are conversion problems, so we should be able to do them because we've done conversions. It's just the same process, but now we're adding a little bit of chemistry into it. Okay, so let's go ahead and look at our equation. This is our first equation here. It says we have 1 mole of N2 reacts with 3 moles of H2 to make 2 moles of NH3, ammonium. Okay, so there's an invisible 1 here. If that helps, you can put that invisible 1 there. Okay, all right, so let's look at our first practice problem. Our first practice problem says how many moles of NH3, that's what we're looking for, would be produced from 2 moles of N2. Okay, so this is kind of straightforward. If we look at our equation, for every 1 mole of this, we get 2 moles. Remember, this number represents the moles, 2 moles of NH3. Well, if 1 mole equals 2, then 2 moles of this would give me 4, right? Because it's twice the amount. So that's the answer for it, but now let's go over how to do that using conversion. So step 1 would be take this number and rewrite it. So we have 2 moles of N2. Okay, that's what I'm starting with. Let me rewrite this here. I have 2 moles of N2. Okay, I'm going to multiply that times a conversion fraction. I'm going to go times conversion fraction. Okay. If I look at the problem, I have moles of N2, but I want moles of NH3. In other words, I have moles of N2, but I want to convert it into moles of NH3. Okay, so I have this, but I want to convert it to this. Okay, so let's look at the problem. Remember, every time we're converting this unit, it goes in the bottom. So I put this unit here, moles of N2. What I want is moles of NH3, so I put that on top. Moles of NH3 go on top. Okay. Now the question is, where do I get these numbers from? Because we know we always put these numbers here, right? Well, if I look at my equation tells me that for every 1 mole of these, I produce 2 moles of this. In other words, 1 mole equals 2. So 1 mole equals 2. So I cancel, equals 2 times 2 gives me 4 moles of NH3. And that would be my answer for this problem. 4 moles of NH3. Okay? Look at another example. So let's say, using the same equation. Also, when we start this, make sure your equations are balanced. This one's already balanced because I have two nitrogens here, 2 nitrogens there, 6 hydrogens, and we multiply this, 6 hydrogens there as well. So they're balanced. So the first thing you do is you check that your equations are balanced. Well, that one was balanced. I didn't check it because I knew it was balanced already. Okay? Let's go on to the next problem. So, next problem is asking us, we're using the same equation. It's asking, how many moles of NH3, so still we're looking for NH3, would be produced from 6.5 moles of N2. So same problem, different numbers. Okay? Because this one we can just kind of think about it, right? But this one might be a little bit more difficult. Let's go ahead and do this one as well. So I'm going to rewrite this. I go 6.5 moles of N2 times a fraction times a fraction. We know this goes in the bottom. That's what we want to get rid of. Moles of N2 in the bottom. I want moles of NH3 that goes on top. Moles of NH3. I use the same numbers. For every 1 mole of this, I get 2 moles of this. So for every 1 mole, I get 2 moles. I multiply that. Remember, these units cancel out because they're the same. That's going to give me 2 times 6.5 will give me 13. I'm left over with this, moles of NH3. Okay, so that's going to be my answer. Okay, now if you need to slow this video down to kind of process what's going on, you can do it as well. Okay, we're going to go through one more problem. This problem is going to use the same equation, but it's going to be slightly different. Okay, so in this next problem, it's asking us how many moles of H2. That's what we're looking for. We're looking for H2 now. We're not looking for NH3. Are produced or are needed to make 30 moles of NH3. So this is what we're given. That's what I'm looking for. Okay, I'm just going to move this up a bit. All right, so I'm going to go through the same process. I'm going to take what I'm given and I'm going to write it down. So I'm going to go 30 moles of NH3. That 3 a little bit better. Times a fraction. Okay, so same process we've been doing since the beginning of the semester. Now let's think about what we want. Well, I have moles of this, right? I have moles of NH3, but I want to figure out how many moles of H2 must have been used in that equation. So I want to eliminate this because that's what I start with, so I put that in the bottom. Moles of NH3. What I want goes on top, so moles of H2 go on top. All right, so now we grab these numbers. So we grab these numbers from the equation. So let's go back up to our equation. My equation tells me that 3 moles of this are needed to make 2 moles of this. In other words, if I go down here, these numbers, for every 3 moles of NH3, for every 2 moles of this, I get 3 moles, I need 3 moles of that. So the 2 is next to this, so I'm going to put the 2 down there. 3 is next to the H2, so I put the 3 there. Okay, so we just set it up. Now we just got to go ahead and do the math. So these cancel out because they're across. So remember, you always multiply the top, divide by the bottom. So if I multiply the top, it's going to give me 3 times 30. 3 times 30 gives me 90. And I'm not going to put the units yet because I want to do the bottom. Divided by 2. That gives me 45. Well, 45 what? Well, I'm looking for moles of H2, right? And that's what I'm left with. So 45 moles of H2. That would be my answer. So just one step conversion, that's all it is. And it's important that we get these down because it's going to become more complicated. If you feel comfortable, you can stop here and just go through the classwork, but I'm going to work through 2 more examples with a different equation. Okay? All right, here's the next problem. We have iron oxide, 1 mole of it, there's an invisible 1 there. We ask for 3 moles of carbon monoxide to create iron plus 3 moles of CO2. Okay? All right, let's read our first problem. First problem says, how many moles of iron would 30 moles of carbon monoxide produce? Okay, let's go same process. What I'm given, I write it down. So I go 30 moles of CO times a fraction. I'm going to multiply this times a fraction. Okay. I have moles of CO2, of CO, sorry. I want to figure out moles of iron. That's what I have, so it goes down here. Remember, it's better to do units first and then worry about the numbers. What I want goes on top. Moles of Fe, iron. Okay, now let's look at our equation. My equation tells me every 3 moles of CO produces 2 moles of iron. Okay, so every 3 moles produces 2 moles. In other words, every 3, so I got this 3 from here, produces 2. Then we just do the math. 2 times 30, this cancels, 2 times 30 gives me 60, divided by 3. 60 divided by 3 is going to give me 20 moles. You can use a calculator for all of these. 20 moles of, well, of this, right? That's what's left over. It gives me 20 moles of iron. That's my answer. Okay? Alright, the last problem is slightly different. It just kind of shows us that we can go, it's not always products, it's not always reactants products or products reactants. We can actually figure out if we use a certain amount of this, how much of this we have to use. Or the other way around. Okay? We'll go slow through this last one. How much iron oxide is needed to react with 60 moles of carbon monoxide? Okay? In other words, I know how much carbon monoxide I have, right? I know how much I have 60 moles of it, but I want to figure out how much of this would it react with. Okay, well, let's go ahead and figure that out. Same process. First, I'm going to write this. What I start with, I'm going to write it down. So I have 60 moles of CO. I multiply that times a fraction. Okay? So I go moles of CO in the bottom, moles of iron oxide on top. Okay, we don't need a periodic table for these as well. All right. Now I'm going to go ahead and put these numbers here. So let's look at our equation. Well, 1 mole of this, right, there's an invisible 1 there. 1 mole of this reacts with 3 moles of that. So 1 mole equals 3 moles. Okay? Or in other words, you can look at it the other way. I need 3 moles of this for 1 mole of that. So I take it from the equation. The equation tells me that for every 3 moles, I need 1 mole of that. So for every 3, I need 1. Yeah, that's it. We just do the math. Cancel, cancel. That gives me 60 times 1 gives me 60 divided by 3. It's going to give me, in this case, it happens to be the same as the top, but that's not always the case. Okay, 60 divided by 3 will give me 20 moles of left with this, right? And it's also what I'm looking for. That's correct. Iron. Sorry, fix that. Iron oxide. That would be my final answer. Okay. If you have any questions, just feel free to shoot me an email.